Hello again, learners. How are you doing? It's your mathematical and research Tunisian Mourad Sultan Ezouidi. Today we are going to focus on the third degree polynomial equation, and I will give you how can you solve third degree polynomial equation, okay, without using the Cardan method, because Cardan method is not, let's say, the appropriate method to solve cubic roots, because it will give you error estimation also, okay? And I will give you an example for you now to solve, okay, and to use the discriminant from the Mourad Sultan Ezouidi that can help you to find the roots of third degree polynomial equation, okay? Now I'm going to start with you, learners. I will give you an example for you now. At the same time, okay, this one, Mr. Mourad, if it is possible. Okay, share. So our polynomial equation has to be like that. Okay. Okay, wait for me. I will. Yeah, this is new, so it will be x3 here. I'll change this one, x3 minus 4x minus learners 4x. Okay. X raised to the power 2, of course. Okay, plus 6 plus 6x. Okay, 6x only, minus 4 equal 0. Okay, we are going to find the roots of this third degree polynomial equation, and we'll show that, let's say, the roots is 2 and 1 plus negative I. Okay, here of course is 3. We'll erase this one. This is, of course, is 2, and this is 1. Okay, and this is negative 2. All the rest I will ignore the rest. Okay, now learners, you can see this is a third degree polynomial equation. Okay, and we should find the value of let's say s minus 1, s0, and s1 and s2. Okay, I'll just here focus on the first coefficient. Here we told is 4, and this one is 6, L1 is 6, L2 is 4. Okay, the rest no need to write them. Okay, so here, learners, I'm going now to work with this. Okay, I want to find, let's say, S1 or S2. Okay, now I'm going to work with S1. S1, learners, is the same formula. Okay, I will use this one, sorry. Again, Mr. Mourad, go back. Okay, I will use this coefficient because these are the only coefficient of my original third degree polynomial equation that I'm tending to solve it, okay, without using the method of Cardan, because the method of Cardan give you error estimation, not always true, okay? But some teachers, some professors, they use it, no problem, but they will never give you exact roots, okay? Because after supposing the 4 s2 squared, 27 s2 squared plus 4 s1 cubed, okay, is the discriminant. In fact, is not a discriminant, okay? If you want to show this for you, I'll explain this for you, no problem. But now I'm focused on my own method, okay? I will continue, learners, to this one. I'm going to copy, if it is possible. Okay, this is a simple example for you, learners, to understand. Now, learners, I'm going to use my of course, S0 for the R is x1 plus x2 plus x3 equal 0. Okay, because I'm working with third degree equation, polynomial equation. Now I'm going to find, let's say, S0 is original formula. We told that is always is equal to 0, learners. No need to check it. Okay, so S0 we told is negative. Is negative. Yes, this one is negative 1 over 3 plus, of course, this is 4. Okay, plus 3 times 4, which is 3 times 4, Mr. Mourad, which is equal to 12 minus 12, okay, equals 0. 12 minus 12 equals 0. Okay, this is the value of S0. Okay, means, okay, okay. Okay, we continue. Okay, we continue now. I'm going to work the value of S1 learners. S1, I will use the formula. I will just focus on this one. Control V, this is the coefficient that I'm going to work. 4, 6, or 4. So it will be S1 is combination. The formula now is 2, you see, because the formula is negative C1, 1, n choose 2. The n is 2, okay? The n here is third degree, yes, it will be 3, okay? Times 4 squared plus 3 squared is 9, plus 3 squared times 6. I will use my calculator, and this one has to be equal to 6. I'll check. Is it 6? Oh, okay. I will use my calculator. It will be negative 3 times 16 plus 9 times 6. This is equal to 6. Okay. This is the calculator. Don't use current method. There is a mistake inside it, okay? It will never give you exact roots, but calculators or MATLAB or GeoGebra, they use graphs and they use the trial, okay? So it will be negative 3 times 16 plus 9 times 6. This one is equal to 6, okay? So now I'm looking for the value of S2. The value of S2, it will be like that. Value of S2, I will erase all of this. This is S2 learners. I need only the first 3 coefficient of, okay, I will write it here. It will be negative S2, it will be 2 times, this is gonna be 3, this is 4, this is minus, okay, 3 minus 2 is 1, so no need to write it. Okay, this is a 3, because you are working with third degree. This is 4, this is 6, okay, and this is 3 cubed, okay, times 4. Okay, this one has to be equal to 20. I will use my calculator learners. Okay, so we have 3 choose 3 is 1. 2 times 4 cubed means 2 times 64. 2 times 64 minus 9, 3 squared times 4 times 6 times 4 times 6 times 4 times 6, 9, okay, times 6 plus 27 times 4. Okay, this one has to be equal to 20. Therefore, this is equal to 20. Equal 20, I will close this one. Okay, now learners, I'm going to write my new polynomial equation, which is that. I will use this one if it is better. I will use this one. Okay. It's very easy, learners. Don't use the current method, okay? Okay. Which here? Therefore, I will write, this is my original polynomial learners. So now my new polynomial is that x cubed plus 6x plus 6x minus 20 minus Mr. Mourad minus 20 equals 0. Okay, now we are going to solve this polynomial x cubed plus 6x minus 20. Okay, so now if we are going to solve this question, I'm going to give you a method. Try to expand this method, this polynomial, our polynomial, this one. You see the first one. Sorry. Okay, now extend your third degree polynomial equation. Okay, therefore we have this one. Okay, for the roots of this learners, the roots are like that. The x roots of my new third polynomial equation of okay, or I will write has roots as roots. I will tell x roots that x roots as the first one learners is 2. Okay. That's one more to have this. Okay. Yes, we told 2. Okay, the next it will be minus 1 plus 3i minus 1 plus 3i, and the last one is minus 1 minus 3i. Okay, learners, here we told that, did you remember when we told x1 plus x2 plus x3 equals 0? Do you remember? I will write it here. And this one, where is it? I thought. I wish that I will find now this one, yes, I will write it. This is x1, sorry, copy. This one, learners, is that so simply because of, I will write here, a 0 equal x1 plus x2 plus x3 equal what, learners? Equal 2 plus, between parentheses, or I will write it as it is, negative 1 plus 3i plus, okay, negative 2 plus negative 1 plus 3i plus, okay, negative 1, no problem, plus minus 3i. Okay, this one has to be equal to 0. In fact, you see, 2 and the minus 1 is minus 2. Minus 2 plus 2 is 0. 3i minus 3i is equal to 0. Now, if you are going to use the method of Gordon, you will never find the same x roots and the same roots. Okay. Now, if you are going to solve this, okay, so I'll just write this as that. I will use this one. Therefore, the roots can be written as that. I will make alpha, it is possible. Alpha, I'm looking for alpha. Alpha, what is alpha? Okay, sigma. Okay, I will make beta 1 or beta k Okay, equal. This is, I will cut it. Beta equal, there is a fraction here, equal L0 of O D Q. Sorry, equal with all the fraction, not exponential. Okay, equal what? Equal L0 of O D Q plus xk plus xk plus xk. Down is k. Okay, this is of course is L0 of the Q divided by 3. Okay, let's see learners here. This one for beta 1 has to be equal to what? I will make this one as that. Equal L0 learners is 4. I will make here 4 plus x1. I will suppose the first x root is 2 plus 2 divided by 3 will give you 6 divided by 3 equal 6 divided by 3, sorry, equal 6 divided by 3 equal 2. This is the first root. Okay, I will use this one better. Okay, equal 6 divided by 3 is 2. This is the first root. The second root learns is that copy. Okay, second root. Shit. Second root I will label as beta subscript 2. Okay, is 4 plus negative 1 plus 3i. I will make here negative 1 plus 3i divided by 3, of course. Plus minus is minus. So it will be what, learns? It will be 3. 4 minus 1 is 3 plus 3i divided by 3 will give you 1 plus I. This is the root, the second root. For the third root of my third original polynomial can be written as that. Okay, just a moment. Beta 3, I will suppose that is the third root. Beta 3 equal, of course, this is okay, this is x1 to be clear with you. This is x2, and this is x3. Correct. Now it will be 4 plus we told minus 1 minus 3i. This one here minus. Now it will be 3 minus 3i will give you 1 minus I. Now if you would like to add all the roots, 2 plus 1 plus 1 will give you 4. Then I minus I will give you 0. If you would like to make the product 2 times 1 plus I times 1 minus I will give you 4 also. If you would like to multiply 2 plus 2 times the product of this, then the plus 1 plus I times 1 minus I will give you 6. Therefore, this is the roots of my first third degree polynomial equation. Now I will give you a method. How can you solve this? Okay. I will extend my own polynomial, my third degree polynomial. Copy. Now extend your third original polynomial equation. Okay, can be written as that. P of x4, I'll make x4 minus 4x cubed plus 6x squared. If it is better to make a power, I will take this one like that. This is x squared. Then this is minus 4x. I did this example to make a proof for the cardinal method that really is wrong. Okay. Okay, so now S1 learners, I will just calculate S1. You can calculate S1 learners. S1, I will use this one if it is better. Okay, S1. S1, I will use this. Okay, I will use this one, no problem. S1. I need S1 or S2 only. Okay. Extend your polynomial, your third degree polynomial equation. So we'll get what exactly when we're here. Okay. Okay, so S1 learners, S1 equal, I will write S1 by calculation, of course. I will write here S1, Mr. Mourad. Okay, I will use this, no problem. Change this with S1. S1 of all the Q, of course. S1, this is S, this is Q, or R, equal, sorry. Okay. The formula told you that is negative combination and choose 2 means negative, for choose 2 is negative 6. Negative 6 times what? Negative 6 times 4 squared, between parentheses 4 squared. Okay. Plus 16, 4 squared is 16, times what? Times 16 times 16 times plus times. Okay, no problem. 16 between parentheses times what, learners? Times 6. So this one you can use a calculator. This is S1 learners. It will be negative 60, negative 6 times 16 plus 16 times 6. So this one is equal to negative 12. Okay, equal negative 12. I'll check again. Okay, it will be negative 6 times 16 plus 16 times 6 equal 0 here, not 12. Okay, again, negative 6 is squared. 16 times 6, why it's negative 12? Check again. So, negative 6 times 16 plus what? 14 times, not 14 times. So it will be negative 6 times 4 squared plus 16 times what? 16 times 6. So this one equals 0. Okay. Now for S2 also, S2, I will write S2 now. This is S2, S2, S2. Okay, I'll make copy for this. I will calculate S2 learners. Of course, you know the formula now. S2 is equal to, I will change this one. S2, this is S2. We can get from my own discriminant formula. It will be 8 times 4 raised to the power 3 minus 32 times 32 times what is the formula? 32, which is 16 times, yes, times 4 times 6 times 4 times 6 plus 64 times okay, 64 times L2. L2 is 4. Here's your calculator, learners, and check the value of S2. So it will be 8 times 64, 4 cubed, minus 32 times 4 times 6 means times 24. Okay, plus 4 times 64 times 64. So this one is equal to 0. Therefore, S2 equal to 0. Now move to S3. S3 learners means now I'm solving this third degree polynomial equation using fourth degree polynomial equation. You see? Okay. To show the method of Cardan is false. So it will be now, okay, I'll check this positive, negative. So it will be negative 3 times 4 cubed, 4 raised to the power 4. Okay, and negative, okay, plus negative. This is plus 16 times 4 squared, 4 squared. I'll make this. Okay, we told 16 times what? Times 4 squared times, between parentheses, L1. L1 is 6. Then minus 64 times 4 times 4 times 4 times L2. L2 is 4 times 4. Okay, plus 256 times L3. L3 is 0 because we are going to work with, you just extend your polynomial. You use your calculator, learners. My own calculator. It will be negative 3 times 6 raised to the power 4 is 256. Okay, plus 16 times 16, because 4 squared, times 6, minus 64 times 4 times 4, yani times 16. This one is equal to negative, okay, equal to negative 256. Equal negative 256. Okay. Therefore, now my new fourth degree polynomial equation can be written as that. Okay. It will be S1 is 0, S0 is 0, S2 is 0. I will just write X. Okay, plus X plus the last term which is negative S3. I will write plus S3. It's better for you. Let you understand first. Okay. S, this is S, this is 3, this is 3, this is Q, or R, whatsoever. Okay. Equal 0. Erase the rest. So, the S4 learners is what? The S3 is negative 256. This will imply, will give me exactly this one. Okay. Minus, copy, minus X4 equal negative negative S3. But S3 is negative, so it will be equal exactly negative. Negative, it will be 256. So x4 equal 256 learners. I'll just comes here. x4, x4. Okay, write it here. x4 equal 256 equal 4 raised to the power what? Okay, equal 4 raised to the power 4 times exponential, copy, times exponential 2k I pi. 2k I pi. Okay, this is x raised to the power 4. Now, learners, to solve this, it's clear that xk is equal to 4 exponential ik pi over 2. Therefore, you can write here, learners, therefore, x, I will write xk, yes, this one, xk, the x roots of my original polynomial, k belonging to from 0 to 3, 0, 1, 2, 3, close parenthesis, equal what? Equal 4, as it is, okay, exponential 2k I pi divided by 4 will give you exponential, I will write here, exponential 2k I pi divided by 4, exponential, okay, exponential ik pi divided by 2, like that, exactly, divided by 2. Okay, so the first root is what? The first root, okay, I will write here, therefore, xk, okay, I will take this again. Therefore, learners, L0 of order, or, okay, this is, I will write alpha or beta, the roots, alpha, theta, whatsoever, beta, okay, equal, I need a fraction, equal L0 of order, okay, equal L0 of order, L0, L0 for the Q, the sum of the roots, plus what, learners? Plus xk, okay, plus xk divided by 4, okay, because now you extend your polynomial equation, equal, if it is possible, I'll make like that, equal, this is L0 of order 4, learners, is 4, I will write here 4, plus, let's say xk from 0 to 3 is 4k I pi, I will write this here, cut, plus 4 ik, okay, now 4 divided by 4 is 1, 4 divided by 4 is 1, so it will be equal to 1 plus, sorry, equal to what? To 1 plus exponential ik pi divided by 2, okay. When k equals 0, it will be, okay, we told that, x4 equal 256. So L0, okay. This is, of course, this is 4 divided by 4 is what? Where is my mouse? Yes, this is what? Okay. Now, if you would like, you can write this as equal. Now I'm going to write the roots. This is, it will be 2, then it will be 1 plus exponent when k equal 1, it will be I. And then I, small I. Then the next, it will be when k equal 2, it will be 1 minus I. Okay, when k equal 3, it will be learners. Okay, we told 1, 0, 1, 2, 2, 2, 2, minus I, minus I. And the rest, it will be negative 4. Okay, and negative 4. And negative 4. These are, okay. We told, okay. Now these are the roots. Okay, so I will erase the rest. Okay, look, learners here. We told that when k equal 0, it will be 1 plus exponential 0, it will be 1 plus 1 gives 2. This is the first root. The second root, when k equal 1, exponential I pi over 2 is I. That's why it's written 1 plus I. When k now is equal to 2, okay, it will be 1 minus 1, which is equal to 0. Okay, between parentheses equals 0, this one. That's why here our polynomial equation, we extended this one, we extend this one, means x has to be equal to 0 here. The third root is 0. And now when x equal, this one I will put into parentheses if it is possible. Okay. And the last one, alpha 3, 1 minus I. 1 minus. So these are the roots. Between these, I will explain this for you. Okay, there is a relationship between the x roots of fourth degree polynomial equation with x roots of third degree polynomial equation. I will explain this for you. Okay, we have L0 of k equal L0 for the cube plus, this is from 0 to 3. I will suppose this is y, okay, this is y, and this is 3. Okay, now I get, let's say, the x roots, learners. Okay, I guess of my Gibbon equation, I want to find yk. Therefore, learners, yk is equal yk equal. You see, this is yk. I will make cross multiplying equal okay equal this equal minus L0 for the cube plus 3 equal minus L0 plus 3. This one you should multiply all of this by 3 and this by 4. 4 L0 of order Q transfer on the left hand side. It will be negative 4 plus 3 times L0, that's why it's written here minus, plus 3 here divided by 4. Now learners, just replacing this one has to be equal, copy, has to be equal to this. Okay, L0 is, we told, is negative 4. Negative 4 plus 3 xk. What is xk? This is xk, learners, is this. You see? This is xk. I will write it here, plus 3 times, okay, plus 3 times, plus 3 times, means, okay. Now divided by 4, it will be what? It will be 1 plus 3 times exponential ki pi, learners, okay. Okay, so now just find yk from 0 to 1. Therefore, I will write this as that. Therefore, this will give me, okay, will give me the first, when k equals 0, I will write them into brackets. 0 it will be, okay, 4. Okay, it will be 4. Then when k equal 1, it will be 1 plus 3i. Okay, the next root, when k equal okay 0, it will be 1 4. When k equal 1, it will be okay 3i, correct. Okay, and 3, it will be minus. So the last one is 1 minus 3i. Close the parentheses. These are the roots. Okay, clear? Of course, he has to be clear, learners. Okay. Thank you for listening, and see you inshallah next time. So we told here negative 4. Sorry, boys, girls, this is negative 4, صح? Negative 4 divided by 4 is minus 1. Minus 1, Mr. Mourad. Okay. So it will be minus 1. This is 2, correct. Now it's correct. Because minus 1 plus 3 is 2. Then it will be minus 1 plus 3i. Then 1 minus i. Okay, plus minus 3i. Now, if we are going to add this, 2 minus 1 is 0, 3i minus 3i is 0. You see this one is the x roots of what, learners? Of the third degree equation. I already explained this before. I would write it here. This one, you see? This is 2 minus 1 plus 3i minus 1 minus 3i. Here, what we told here before. Here you can say x1 here, y0, for example, x2 here, y1. Okay, so it will be 2, this is 2, minus 1 plus 3i, minus 1 plus 3i, minus 1 minus 3i. Okay, now if you are going to use the method of Cardan, you will find a mistake. You will tell the method of Cardan is not correct. Okay, to solve this. So our original polynomial is that, is this, isn't it? I will explain this later, inshallah, another time. Okay, I feel that I'm tired now. Thank you for listening and goodbye. I will, okay, save this as third degree equation. Third degree equation. Third degree equation. Third degree polynomial equation. Polynomial equation solved by Mourad Sultan Ezouidi. Good man. Okay. Thank you and goodbye. Yes. Okay. I'll close my own calculator. I feel I'm tired now. I'm going to relax. Okay. Thank you and goodbye, Mourad.